Okay, so we have to discuss the topic which is called computing components. In this chapter, we hope to deal with the inside things of the computer, and we need to understand them a bit and the logic that you can give in support of the need to understand the insides of a computer in order to go through this course. Is that when you have to when you have to purchase a computer of any type, for example a tablet computer or a mobile computer or anything like that, so you should make a decision which is an intelligent decision, so you don't fall for false advertising or things like that. So preventing yourself from those scams, you need to understand what computer hardware is all about and how you have to think about computers for purchase decisions. And by the way, in the modern organizations, this is one of the biggest decision a manager has to make when they have to buy devices for their employees for their working environment. And this is where most of their a large amount, if not most of their budget, if goes to. So your budget, a very large amount of your budget is going to go for your organization. It is going to go for purchasing hardware and devices. So you need to know a little bit about what computer hardware is all about. So when you look at the computer case, you can see that there can be different shapes of a computer case. It can be you know um, a separate, you can say, tower casing. We call it tower casing. It could be an all-in-one computer, so everything is embedded inside the monitor of the computer. Similarly, it can be a convertible tablet case, or it can be a laptop, or it can be a tablet, or it can be a gaming console. And there can be different devices which are all having some kind of computer inside. So you need to know. And by the way, when you are even purchasing a digital camera, a DSLR maybe. So you need to pay attention to its compute computational capabilities, and it's not all about optics nowadays. So it has come more towards the side of computing as compared to the physical capabilities or features of the computer. So what does a computer look like from the inside? This is the inside of a desktop computer, and here you can see that the first part you can't you have to notice is the power supply and the fan. And power supply is something which converts your power from the wall into voltage levels which are so small that if you touch this side of the power supply, any copper connector on this side, you will not get any shock. The electric shock will be negligible. Actually, it won't be there, so you won't notice anything. But if you touch the electric terminals on this side, you will get a very bad electric shock, and you can actually get really badly hurt by having. So this power supply protects your computer hardware from bad electricity, you can say. And at the same time, it provides all the different electricity levels that the computer requires. The second thing you notice inside is called the so this is the motherboard. And the motherboard is the housing for everything electronically, right? So here you can see this big blue board on the back. So this big blue on the back is something, this board is something, everything else connects on top of it, right? So the main things that connect are listed over here, like the sound card, the card which is responsible for converting my sound into electricity, or taking the electric signals or the digital electric pulses and converting it back to me through speakers as sound. This is the circuit which is responsible for that. And then there's a video card which is responsible for taking digital signals, numbers and digital electric signals, and converting them into a format which can be seen on monitors or TV screens. And it works the other way around as well. So for example, you have a webcam, it receives the webcam data and translates it into digital numbers or electric signals, you can say, and feeds it back to the motherboard. Then there is something called a processor and something called a memory. So these two things, if I may, let me write it down over here, that if someone asks you what is the brain of the computer, so how would you answer that? So you will say it consists of two parts. Brain of the computer consists of two parts. The first part is called the processor, also called CPU, which is short for Central Processing Unit, right? How do you define the computer? Computer is just a piece of hardware. It's not even the software that is running on top of it. So computer is something which is a piece of hardware which is able to give processing power and stuff like that. But now we are coming inside the computer. So this picture showed us that we are actually gone inside that computer, which previously we used to look at like this, like a black box. Now we don't look at it just as a black box. It is much more than that. There are two things inside which are really of interest to us. One is called the processor, and one is called the memory module, right? So let me tell you over here. So processor, which is also called a CPU, short for central processing unit, is one part of that brain, and memory is the other part of your brain, or sometimes it is also called a RAM, which is short for random access memory, right? Okay, this different types of informations. All of these informations, particular specific pieces of knowledge, they're stored inside one part of my brain. While at the same time, when someone asks me, what will you do if uh, if there is rain outside, will you go to the office or not? How the answer will be calculated, it's another part in my brain. There is a part which is able to take the information which is already stored in our brain, and it calculates new results based on that information. And that is what the basis has become for implementing machine learning and artificial intelligence. Now we do that, we have implemented artificial intelligence just by modeling the working of human brain, right? That's why we have used the term artificial intelligence. So this is something you need to keep in mind, that our computers also has these two specific parts. One part is something which is called the memory or the RAM, which is the part which stores the most important information in my brain. Like the RAM can have my files, my everything that I'm currently running. For example, this Zoom session, my picture, your names, they are all being saved in everyone's computer's memory in runtime. We call it runtime or real time, you can say, and it is continuously being updated. That's another thing. But these information are being stored. At the same time, you may have noticed that my picture has the background removed. All the background is artificially being removed by this software. This green screen is being placed in runtime using the other part of the brain of the computer, which is called the processor, which is taking my picture as information and processing that picture and converting it to something better. There are certain other things that we need in order to make the best use of these two things, which are the CPU, the processor, or the memory. And those parts are sometimes called, one of those are called sound card, video card, the power supply, and the fan, and the heat sink that is responsible for an important thing. And all of these things, every single thing in the computer will be connected to something that is called the motherboard. So the motherboard is something that allows you to connect all the devices, the CPU, the memory, the sound card, the video card, the power supply, and many, many more things that you can find out in the market, and you can just take them and plug them on top of this motherboard. So it needless to say that the motherboard needs to be of a very good quality, and it needs to come from a good manufacturer. So if it is not up to the mark, you will see a very a downgrade in your quality, and that will actually affect the performance of the CPU and memory. So a bad purchase decision would be if you buy a very good CPU and a very good memory module, and you connect it to a very bad cheap quality motherboard. Your processor and memory are going to be you can say, not, they're not going to perform properly, they're going to just be wasted. So it would have been better that you would have bought a cheaper CPU and memory as well, if you had to buy a cheap motherboard. So this is one knowledge that you need to know, have, if you want to make good purchase decisions when it comes to computers and buying the computers. So the CPU is the part which interprets and carries out the basic instructions that operate your computer. While uh, in modern days, in current times, you see processors with multiple processors inside. So when you purchase a mobile device, you see that they have written that there are 8 processors inside. So actually, when you open up your mobile device, you can see only one processor. It's a dark gray thing with not even the terminals are not visible, but it contains 8 different you know uh, 8 different processors inside of it, inside the same housing, right? So of course it will increase your functionality in several ways, like you know um, better performance, better throughput, better reliability, and stuff like that. So if you get to know the CPU better, you find out that the processor contains 2 parts. One part is the ALU, this part, and the other part is the control unit. So this is the part where actually the decisions are made inside the processor, and this is the part which brings in the information needed to make these decisions, right? So this information is originally available inside the memory, by the way. So this information is brought in from the memory inside the processor to facilitate the decision making process by the what we call the control unit. And once the control unit receives the instruction, the data, the information that is required for by the processor to make certain decisions in this part, the control unit sends that information to this part, and this part performs different calculations, different decision making steps in order to what you can call is making following commands in summary. So the easiest way of saying what is going on over here is that there are commands, instructions written inside memory. So the control unit, which is inside the processor, brings in those instructions, and then it sends the data of those instructions to the ALU, which is called the arithmetic logic unit, which performs different calculations and different logical decision making steps or things, works with the data, and then it takes certain decisions, and those decisions are obviously sent back inside the memory to be stored as data, so that the user is able to see, and the user calls it information, and that information is now visible on the output devices which are connected to this computer. So this is the complete you can say picture, and obviously the commands, the instructions, the data must have come from somewhere. So the most common place for the data to arrive from is using the input devices. So the data is brought into the computer using the input devices, and then it is sent to the processor. So yeah. Okay, so right, so this thing, all of this thing, you can say, is the most vital part of a computer. And this, on the other hand, this thing which is underneath is something that is, you can say, it is there to support the working of the working of this computer, right? Yeah. So the main part is the storage device. Storage devices are hard disk drives or CD drives or flash USB flash drives. These store your data without the need of electricity being there at all times. They require electricity to store the data, but once it is stored over here, you don't need electricity to retain the data. You can just plug it off, and you can carry your data around anywhere. So you must have seen USB flash drives or portable hard disk drives, portable SSDs which you can carry with you. So once we need to store new data inside these devices, since these are electronic devices, we will have to plug them in to some power source. Once you're done storing the data, you can just plug the device off. So let me show you yeah, this thing. This is something that I carry with me. This is a portable hard drive, right? So this is the connector, and I need this connector to be plugged. So this is a power cable as well, right? So when we give this hard disk power through this thing, and then we store data through the same cable as well. And once the data is stored, I can just, but the data will not go anywhere as long the data will stay there. So that is what I was referring to. So understanding the storage device in this way also gives you the information that this is not the vital part of your computer. The vital parts are these things. And nowadays you see computers which don't have the permanent storage devices. They are relying on cloud storage, on network based storage to store data. And the but all of these things must be there. These things are there, and then you send the data through the network to the remote device on cloud storage. And you don't have a good size storage in your computer. A very basic size storage works, and the real data is actually going back to the cloud storage. Yeah. So, and this slide shows the inside working of the processor and the memory. So this is your processor, and this is your memory, and all the data comes from the memory, data and information, and all the data and information go back to the memory. So when it is coming from the memory and going to the CPU, it is called fetch cycle. So during the fetch cycle, the data and memory, they are coming from the memory and going to the CPU, the processor. And once the processor receives, or the control unit part of the processor receives this data, the processor decodes or tries to understand what the data is trying to say, what the instructions are trying to say about the data. So it is called the decode part. So the instruction is decoded into different parts. One is the command part, and one is the data part. So the control unit is doing all of those things. And then the third phase is that the actual decision making, as I was referring to this part before, the decision making or the calculation phase occurs. We call it execute, right? So the instruction is being executed, and as soon as it is executed, the results are generated, and we don't have, the processor doesn't have a good space to store the results, so it immediately needs to get rid of these results and not just like waste them away. It needs to get rid in a way that it sends it back to the memory in the proper location inside memory, and that phase is called store. So now the results are stored back inside the memory so that user can see the results as information if they want to, or they can just be there for later use, right? So this is called collectively, all of this is called machine cycle. Yeah, so this is called the machine cycle. And machine cycle is something which is the inner working of your processor and your memory inside your computer. So then comes the a little more information about the processor. The processor contains registers that are temporary. So just as I made a comment about the processor over here, that the processor doesn't really have too much space, but it doesn't really mean that it doesn't have any memory or any space to remember data or information at all. So it has a tiny memory associated with this inside of this thing, and that tiny amount of memory is technically called the registers, and sometimes it is also called what we call cache or cache memory. But as long as we don't see the word over here, you don't need to know this. But because I've been stressing too much this time in this semester about the importance of studying this chapter, and which is that you need to make well aware decisions, better decisions to buy good computers with a competitive price. So this word is really important. The cache word is really important. Why? Because it is the memory of the processor, right? So the bigger the better is the thing I must tell you, that the processors must have good amount of caches, and these are really expensive, relatively expensive types of memories. So you don't really find a big cache in cheap processors. So when you go for cheap processors, you will find that the cache memory is very low. But if you go for expensive processors, you will find that the cache memory inside the processor is big, relatively big. Of course, it won't be in gigabytes; it is like in megabytes. But relatively, it is more than cheaper. Yeah, and the second thing you need to know about the processor is the system clock, and the system clock is like heartbeat of the processor. So the and in computers, unlike humans, it is good to have high bit rate or high system clock, you can say. Sorry, not bit rate, cycles per second. So our heartbeat needs to be on a lower side if we want to stay healthy. But the processors, they need to have their the heartbeat, that is the system clock, to be on the higher side, very fast. So Samsung Galaxy A02 is a phone which is of course just like a computer. So it's a computer and it has a processor and memory, but it's like I think 10-20,000, very cheap phone. And if you look at the processor which is under the platform thing, you can see that it's an octa-core processor, means it has 8 processors in one housing, and the maximum speed of each of those processors is 1.8 gigahertz. The heartbeat, how fast it beats. So the heartbeat of this computer is billion 1.8 billion per second, right? Not million, billion. So 1.8 billion per second. But if you go to the even the higher end device, which is this one, you find out. And by the way, this is, I think, I hear it is pretty expensive. I don't have this, but I hear that it's like 200,000 something in Pakistan. So the CPU, it you can see over here that the CPU of this device, the heartbeat of the fastest core of this CPU has 2.9 gigahertz, right? So you can right away compare that this processor is the heartbeat of this processor is 1.8 billion per second, while the heartbeat of this processor, which is in the expensive phone, is 2.9 billion per second, which is really actually crazy fast. So the leading manufacturers of processors are Intel and AMD. You can find in Pakistan all both the manufacturers, the computers with the processors from both the manufacturers, and of course Intel is leading the game. And this is the processor. By the way, in this picture, if I try to zoom in a bit, and we look at this, yeah. So in this picture, this is the processor and this is the fan, and there is a big metal piece between the processor and the fan. So of course the fan is for cooling of the processor, which is this one, but in sandwiched between the fan and the processor is something that we call the heat sink. So heat sinks are really important, and they are used to lower the heat of processors. And then there is liquid cooling technology. uh, yeah, so what happens is that they manufacture, or actually these are not actually, yeah, so there are companies out there who are manufacturing computers which have pipes, fat pipes which are running water or coolant inside, and that coolant goes on top of the processor heat sink. These pipes, and on top of this there are fans and pumps, just like in your cars. So what happens in your cars is there's a radiator. In front of the radiator there are fans, and from the radiator there are pipes coming in the older cars, not new ones. The pipes are coming, and those pipes are going to the engine, and though the water is being circulated using the pumps, and which are somewhere over here. And the pumps, they pump the cold water inside the engine and brings or pumps out the hot water from the engine. Just like that, on the same principle, we are actually nowadays cooling high performance CPUs or processors as well. Similarly, you have other technologies like cooling pads you place under your laptop, and they keep them cooled down. Yeah. So home and business users choose cloud computing is when you place the computational and storage power far away, like in the United States, and you're living in Pakistan, and you have very low performance computers here, but you're making use of the high end computational power and storage from the US directly at your end in Pakistan by using the network capability that we have here. Right now, you see that we have fiber optics, and we have like very high speed networks everywhere. So it's very easy to do that. So we use Google Drive to store our data and our files. So it allows us to use accessibility, like it is accessible. The power, the computational storage power, are accessible from anywhere, and there are cost savings because you don't need to invest in very strong, high performance local computers, your personal computers. You save the space because if you are having like 10 hard disk drives in the United States, giving you the illusion of one collective storage space, it will cost you save you space in in your home. And scalability means that you can share different types of hardwares while you're implementing all of data representation is something which is how you represent your data. The main things that differentiate data representation are analog and digital. So the analog representation is when that is the cloud computing only for storage purposes. So the answer is no, because it comes in various different shapes, like and different features. Like the Google Drive is everyone is familiar with, right? So everyone knows that we use cloud computing for storage. But what if I didn't really have? Let me show you an example for that. My objective, my need is that I want to edit my photographs. My computer is a very slow computer, very old computer, for example. So what I do is I go to pixlr.com, and I start the Untitled, maybe. So I think I had started this, maybe some, right. So here you can see that I am able to use this, what we call web application. This is a web app which I have not installed in my computer. So if for those of you who have used Adobe Photoshop, they know that it looks very similar to Adobe Photoshop. There are layers, there are tools to select my page. So let me try to open a an image from my computer. So yeah, so I can crop this image like this. This is an image. I was telling you guys that I can like I can so these are things which are really uh, which require a good computational power from your computer. But so let me see if I can find filters. Yeah, so there are the filters. Like you can add glitch effect of like fringe effect, and you apply. Your computer may be small and less capable, but it is able to do big things, right? So now let's come to the data representation part. And data representation is when you want to represent your data in different ways. If the I am talking to you, so if I want to plot my sound volume, I could draw this waveform. This could be when I go low in my voice, this is that. When I go high in my volume, I go this is how. So but when I draw the same waveform in digital format, the waveform will look something like this. I hope you guys can slightly feel that these both of these are actually the same signals. Can someone see the similarity between both of these? So these are actually number values. This is one number, this is another number, and this is a very small number, right? Whereas here you can see that there is no break between these values. There is no breaking of values, right? So this is what analog and digital really in reality is. Analog is also called continuous, and continuous means that there is no breakage between things, between two values of the same signal, while digital means that there is different on different time intervals the signal is either on or it is off. So between these two things, these two lines, you can say the signal is off, and on the line it is on. So on off, the switching of signals is what is taking place in digital signal.